Imagine a world where machines understand and generate human language with near-perfect accuracy. How would that reshape our interactions with technology? Welcome to the fascinating realm of natural language processing, or NLP, a field of artificial intelligence that is fundamentally transforming the way we communicate with machines. In the past few years, NLP has taken giant strides forward, thanks to advancements in deep learning and the emergence of transformer architectures. These technologies allow machines to comprehend, generate, and even creatively write human language with increasingly remarkable skill. It's like watching a child grow up, learning from each conversation, each story, each piece of text it encounters. Take, for instance, the groundbreaking language model GPT-4. It's not just a step up from its predecessors, it's a giant leap. GPT-4 has shown us that machines can understand context, coherently generate text, and even answer questions or summarize text with impressive accuracy. Think about the possibilities. From automating customer service to assisting with education, the applications are boundless. But it's not just about creating smart machines, it's about making these technologies accessible. By harnessing vast data sets and developing efficient pre-training techniques, we're making it possible for even smaller organizations to tap into the power of advanced language models. Yet with great power comes great responsibility. As we teach machines to mimic human language, we must also tackle the challenge of bias and ethical considerations. After all, our goal is to create AI systems that not only understand our language, but also respect our values of fairness, transparency, and inclusivity. The future of NLP is a thrilling frontier, a place where science fiction becomes reality. It's a world where your digital assistant doesn't just understand your commands, but also your jokes, your nuances, your context. It's a world where technology doesn't just serve, but also understands and relates. As we delve into the advancements of NLP, remember this question: how will these developments influence our everyday lives? This is not just about what machines can do for us, but also about the kind of relationship we want to have with technology. Stay tuned as we explore this exciting journey into the future of natural language processing. To appreciate the future, we must understand the past. The journey of NLP began in the 1950s. In this era, the focus was largely on creating rule-based systems, where linguists manually crafted sets of rules for machines to follow in deciphering human language. This method was painstakingly slow and lacked scalability, but it laid the groundwork for what was to come. As we moved into the 1960s and 1970s, the concept of machine translation started to gain traction. The idea of a machine that could translate one language into another was a tantalizing prospect. However, the early attempts were fraught with challenges due to the complexity and nuance of human language. It wasn't until the advent of statistical methods in the 1980s that we saw a significant leap forward in machine translation. The 1980s was also a period where we saw the emergence of machine learning approaches to NLP. Instead of relying on predefined rules, machine learning models learned from data, identifying patterns and making predictions. This shift marked a significant departure from the manual, rule-based systems of the past, paving the way for more robust and scalable NLP applications. As we entered the 1990s and early 2000s, the field of NLP witnessed another profound shift with the advent of the internet. The web brought with it an explosion of digital text data, providing a rich resource for training NLP models. During this period, we also saw the development of important NLP techniques such as part-of-speech tagging named entity recognition and sentiment analysis. However, it was in the 2010s that NLP truly started to come into its own. The introduction of deep learning techniques marked a turning point in the field. Deep learning models, with their ability to learn hierarchical representations from raw data, demonstrated remarkable success in a wide range of NLP tasks, from machine translation to text generation. One of the key innovations in this period was the development of word embeddings, such as Word2, Vec, and Glove. These models represented words as high-dimensional vectors, capturing semantic and syntactic relationships between words in a way that had not been possible with earlier methods. Yet, despite these advancements, deep learning models still struggled with understanding the context in which words were used. This limitation was addressed with the introduction of recurrent neural networks, RNNs, and later long short-term memory, LSTM networks. These models were capable of processing sequences of data, making them well-suited for handling the sequential nature of language. However, even these models had their limitations. They were not very effective at handling long sequences due to the problem of vanishing gradients. And they processed sequences in a linear manner, which was computationally inefficient. This brings us to the most recent and perhaps the most revolutionary development in the field of NLP: the introduction of transformer architectures. Transformers, first introduced in the seminal Attention is All You Need paper in 2017, marked a significant departure from previous approaches. They discarded the sequential processing of RNNs and LSTMs in favor of a more parallelizable approach, using a mechanism known as attention to weigh the importance of different words in a sentence. This allowed them to handle longer sequences and capture more complex linguistic patterns. The introduction of transformer architectures marked a significant milestone in the evolution of NLP. The transformer model laid the foundation for the development of powerful language models like BERT, GPT-2, and their successors, which have since pushed the boundaries of what is possible in NLP. Looking back, it's clear that the field of NLP has come a long way since its early days. From rule-based systems to machine learning, deep learning, and now transformer models, each step in this journey has brought us closer to the goal of creating machines that can truly understand and generate human language. As we look to the future, there's no doubt that the next chapter in the evolution of NLP holds even more exciting possibilities. In 2017, a new era in natural language processing dawned, the era of transformers. With this, the landscape of NLP was forever changed as transformer models like BERT and GPT entered the scene. BERT, or the bidirectional encoder representations from transformers, was a game changer. It was the first to leverage transformer architecture, enabling it to understand the context of a word based on all of its surroundings, to the left, to the right, and everything in between. This ability to consider the entire context of a sentence, regardless of a word's position, marked a significant advancement in NLP. Then came GPT, or Generative Pre-trained Transformer, which took a slightly different approach. Instead of reading the entire input at once, GPT reads from left to right, predicting each subsequent word based on the ones that came before it. This made GPT a powerful tool for generating human-like text, a capability that was further enhanced with each iteration, culminating in the most recent marvel, GPT-4. But what made these transformer models so revolutionary? To answer that, we need to delve a little deeper into their inner workings. At the heart of these models is the concept of attention. This mechanism allows the model to focus on different parts of the input when generating each word in the output. In simpler terms, it lets the model decide which words are important and which are not, based on the task at hand. Imagine you're trying to understand the meaning of a sentence. You don't give equal weight to each and every word, do you? Some words are more important than others, and the importance of a word can change based on what you're trying to achieve. That's precisely how attention works in transformer models. It allows them to capture complex linguistic patterns by understanding the relationships between words and their context. These transformer models have proven highly effective in tasks such as translation, text summarization, and sentiment analysis. They've reshaped content creation, customer service, and even education by automating processes that once required human intervention. With the ability to understand and generate human language with remarkable accuracy, these models have brought us one step closer to truly conversational AI. But transformer models aren't just about understanding and generating text. They are also about learning. Pre-training and fine-tuning have become essential components of these models. In the pre-training phase, models learn from vast amounts of text data, getting a grasp on language patterns, grammar, and even some world knowledge. In the fine-tuning phase, they adapt what they've learned to specific tasks, making them incredibly versatile. The introduction of transfer learning approaches, where models are pre-trained on large corpora of text data before fine-tuning on specific tasks, has been another major milestone. This approach has made it possible for even smaller organizations to leverage these powerful models, democratizing access to state-of-the-art NLP technology. As we marvel at the capabilities of transformer models, it's important to acknowledge the challenges that come with them. With great power comes great responsibility, and as these models become increasingly proficient in understanding and mimicking human language, they also risk inheriting and perpetuating biases present in the data they're trained on. These ethical considerations are a crucial part of the conversation around transformer models and NLP at large, and we'll delve into those in a later scene. For now, let's take a moment to appreciate the transformative impact of these models on NLP. From BERT's bidirectional understanding to GPT's impressive text generation, these models have revolutionized our approach to language understanding and generation. And yet, as transformative as these models have been, they were just the beginning. The arrival of GPT-4 took NLP to new heights, setting a new standard for what machines can achieve when it comes to understanding and generating human language. But that's a story for the next scene. These models, however, were just the beginning. The arrival of GPT-4 took NLP to new heights. GPT-4, the latest iteration in transformer models, has redefined our understanding of machine language capabilities. This cutting-edge language model, a product of relentless innovation in natural language processing, or NLP, has taken a quantum leap over its predecessors. Imagine a language model that understands not just the semantics of language, the meaning of words and phrases, but also the syntax, the rules that govern how words are combined. Now extend this model's grasp to context, the nuances that give words their true meaning in a particular situation. That's GPT-4 for you. It's a linguistic maestro that can comprehend, generate, and even improvise language with an uncanny resemblance to human conversation, but that's not all. Beyond mere language generation, GPT-4 has capabilities that reach into the realms of text summarization, translation, question answering, and even creative writing. It's like having a multilingual wordsmith at your fingertips, ready to weave a sonnet or summarize a novel, answer your queries, or translate your thoughts into any language. Consider text summarization. GPT-4 can read through a lengthy document and distill its essence into a concise summary, saving hours of manual effort. It's like having a personal assistant who can sift through mountains of text and present you with the nuggets that matter. Then there's translation. GPT-4 isn't just bilingual or trilingual, it's polyglot, capable of translating between multiple languages with an accuracy that rivals professional translators. It's as if you have a United Nations interpreter in your pocket, ready to break down language barriers at a moment's notice. And when it comes to answering questions, GPT-4 can parse complex queries, delve into a vast knowledge base, and come up with answers that are not only accurate but also contextually relevant. It's like having a knowledgeable companion who can answer your questions on a dizzying array of topics. Finally, let's talk about creative writing. With GPT-4, you can generate poetry, pen a short story, or even draft a screenplay. It's like having a creative partner who never runs out of ideas and can help you express your thoughts in the most eloquent language. The applications of GPT-4 are vast and varied. From content creation and customer service automation to educational assistance, GPT-4 is poised to revolutionize numerous sectors. Small and large organizations alike are leveraging this state-of-the-art language model to streamline operations, enhance customer interactions, and create engaging content. But the rise of GPT-4 isn't just about technological advancements, it's about the convergence of efficient pre-training techniques, vast datasets, and transfer learning approaches. By pre-training on a large corpus of text data and then fine-tuning on specific tasks, GPT-4 has been able to learn at an unprecedented scale and speed. This approach has democratized access to cutting-edge NLP, enabling even smaller organizations to harness the power of GPT-4. However, with great power comes great responsibility. As we marvel at the capabilities of GPT-4, we must also grapple with challenges related to bias, fairness, and ethical considerations. As these models become more adept at mimicking human language, they also risk inheriting and perpetuating the biases present in the data they are trained on. Addressing these challenges requires concerted efforts from researchers, policymakers, and industry stakeholders. We need to develop robust strategies to mitigate these biases and ensure that our AI systems uphold principles of fairness, transparency, and inclusivity. The task is daunting, but the stakes are too high for us to shy away from this responsibility. With GPT-4, the future of NLP seems promising, but it also brings forth new challenges. As we stand on the cusp of this new era in NLP, We must navigate these challenges with wisdom and foresight, ensuring that our AI technologies serve us well and uphold the values we hold dear. As with any technological advancement, the progress in NLP raises questions about bias, fairness, and ethical considerations. In our journey of exploring the advancements in natural language processing, we've marveled at the power of GPT-4, the role of transformer architectures, and the promise of transfer learning. But as we stand at this exciting frontier of AI, it's important to turn our gaze towards the challenges that lie ahead. One of the key challenges that arise with AI models like GPT-4 is the issue of bias. You see, these models learn from vast amounts of data, much of which is generated by humans. And as we know, human language and behavior are often riddled with biases. These biases, subtle or overt, can seep into the AI models during the training process. The result? An AI that may unintentionally perpetuate harmful stereotypes or discriminatory practices. This is particularly concerning when AI systems are deployed in sensitive areas, such as hiring, lending, or law enforcement, where biased decisions can have real-world, detrimental consequences. To tackle this, the AI community is focusing on the development of fairness-aware algorithms. These are designed to identify and mitigate the biases in AI system outputs. Techniques like bias detection and data augmentation are being used to ensure that the AI doesn't just parrot the biases in its training data. Instead, it should strive to promote fairness, even when the data it learns from is inherently unfair. But addressing bias is just one part of the puzzle. The development and deployment of NLP technologies also raise critical ethical considerations. As AI models become more sophisticated, they become more opaque. This lack of transparency can lead to what's often termed as the black box problem in AI. To ensure that AI technologies are not just powerful but also trustworthy, we need to shed light on this black box. This is where explainable AI, or XAI, comes into play. XAI techniques aim to make the decision-making process of AI models more transparent and understandable. By doing so, they can help us understand why an AI model made a particular decision or prediction. This in turn can foster accountability and trust in AI systems. In addition to transparency, there's also the question of privacy. As we've seen, AI models like GPT-4 depend on large amounts of data for their training. But this raises concerns about the collection, storage, and use of personal information. How do we ensure that the use of data for training AI models doesn't infringe on individual privacy rights? This is a complex issue that requires robust regulatory frameworks and careful consideration of ethical boundaries. Lastly, there's the matter of inclusivity. AI models should not only be fair and transparent, but also inclusive. They should understand and generate language that is respectful and inclusive of all individuals, regardless of their race, gender, age, or cultural background. This is a formidable challenge, given the diversity and complexity of human language and culture. But it's a challenge that the AI community is committed to addressing, with ongoing research and development aimed at making AI models more culturally sensitive and inclusive. In conclusion, the road ahead for NLP is not without its challenges. From bias and fairness to transparency, privacy, and inclusivity, there are many hurdles to overcome. But these challenges also present opportunities for innovation, learning, and growth. They push us to develop better algorithms, design more transparent models, and foster a culture of ethical AI development. Addressing these issues is crucial to ensure that the advancements in NLP benefit all of humanity. As we continue to push the boundaries of what's possible with NLP, let's also ensure that we navigate this journey with a keen awareness of these challenges and a steadfast commitment to addressing them. After all, the goal of NLP and AI in general should not just be to mimic human language, but to enhance our understanding, foster communication, and ultimately, make the world a better place. The rise of AI technologies has sparked intense discussions around their ethical implications. As we delve into the world of AI and its growing capabilities, we cannot overlook the imperative of algorithmic fairness. This concept speaks to the heart of ethical AI, focusing on mitigating biases that may be inherently present in these intelligent systems. These biases, often a reflection of the data the machines are trained on, can lead to discriminatory outcomes in sensitive areas like hiring, lending, and criminal justice. Therefore, the quest to design fairness-aware algorithms, detect bias, and implement data augmentation strategies is not just a technical challenge, but a moral one too. It is about ensuring that the benefits of AI are available to all, without prejudice or discrimination. Transparency and accountability are two other pillars that hold up the edifice of ethical AI. As AI systems become increasingly complex, it's crucial to keep their decision-making processes transparent. Enter the realm of explainable AI, or XAI. This field aims to unravel the intricate inner workings of complex AI models, offering insights into how they reach decisions. XAI is about making AI understandable and interpretable, enabling stakeholders to scrutinize AI-driven outcomes. In essence, it's about fostering trust, a critical ingredient for the responsible deployment of AI. But ethical AI doesn't stop at fairness, transparency, and accountability. It also encompasses the critical issue of data privacy. As AI-powered systems proliferate, they raise pertinent questions about the collection, storage, and usage of personal information. Balancing the need for data to drive innovation and the imperative to protect individual privacy rights is a tightrope walk. It calls for robust regulatory frameworks and enhanced data security measures. It's about ensuring that as we harness the power of data, we do not trample upon the rights of individuals to their privacy. Efforts to address these issues are underway across the globe. Researchers are tirelessly working on developing techniques to reduce bias and increase transparency in AI. Policymakers are grappling with the creation of comprehensive regulations to safeguard data privacy. Tech companies are taking steps to incorporate ethical considerations into their AI development processes, and individuals too are becoming more aware and vocal about their rights in an increasingly AI-driven world. These discussions around ethical AI are not just academic. They have real-world implications that touch every aspect of our lives. From the news articles we read, the products we are recommended, the loans we are granted, to the job offers we receive, AI influences it all. And with that influence comes a responsibility to ensure fairness, transparency, and respect for privacy. It's clear that the path to ethical AI is not a straightforward one. It's a journey fraught with challenges and dilemmas. But it's a journey we must undertake, nonetheless. For at stake is not just the success of AI, but the very fabric of our societies. But here's the good news. The very nature of these challenges also provides us with an opportunity to shape AI in a way that reflects our shared values and ideals. An opportunity to ensure that AI is not just about intelligent machines, but also about wise and ethical decisions. An opportunity to create an AI-driven world that is fair, transparent, and respects the rights of all its inhabitants. So, as we marvel at the technological wizardry of natural language processing and its advancements, let's not lose sight of these ethical considerations. Let's remember that the goal of AI should not just be about creating machines that can understand and generate human language. It should also be about ensuring that these machines do so in a way that is fair, transparent, and respects our privacy. As we continue to advance in the field of NLP, these ethical considerations will remain at the forefront of discussions. Over the past 30 minutes, we have journeyed through the evolution of natural language processing, its advancements, and the challenges it presents. We have delved into the heart of the latest advancements in NLP, highlighting the power and potential of transformer models. These models, exemplified by the state-of-the-art GPT-4, are reshaping our understanding of what machines can comprehend and generate in terms of human language. With each iteration, they're becoming more adept at capturing complex linguistic patterns, demonstrating a deeper understanding of semantics, syntax, and context. Beyond mere language generation, GPT-4 has showcased impressive capabilities in text summarization, translation, question answering, and even creative writing. These advancements are not just fascinating for AI enthusiasts, they hold immense potential across various applications. From content creation and customer service automation to educational assistance, the possibilities are vast and exciting. We also discuss the role of efficient and scalable pre-training techniques, coupled with vast data sets, in fueling the rapid evolution of NLP. Transfer learning approaches have become increasingly prevalent, enabling even smaller organizations to leverage state-of-the-art language models for diverse applications. But as we revel in these advancements, we must not lose sight of the challenges ahead. The ethical considerations in AI, particularly those related to bias, fairness, and transparency, are of utmost importance. As AI models become more proficient at mimicking human language, they also risk perpetuating biases present in the data they are trained on. This calls for concerted efforts from researchers, policymakers, and industry stakeholders to develop robust mitigation strategies. We've touched upon algorithmic fairness, the need for transparency and accountability in AI decision-making processes, and the importance of data privacy and consent. These ethical considerations are crucial as we continue to navigate the uncharted territories of AI. As we look into the future of NLP, we must continue to navigate these challenges, ensuring that our technological advancements serve to enhance, not hinder, our collective well-being.